Okay, so let's pull up the whiteboard, and I'm going to do Chapter 6 and Chapter 7. First of all, you need to pull out your outlines, because I'm going to make a change to your outline. Okay. On your outline, Unit 3 says we're going through 6, 7, and 8. I want you to circle 8 and 8.1, 8.2, whatever, and put move to Unit 4. So Unit 3 is just going to be 6.1, 6.2, 7.1, 7.2. 4 sections. Okay? So everybody should ace this test. Somebody won't. Somebody will break the amble with a banana. But, no. 7, 6.1, 6.2, 7.1, and 7.2. That's Unit 3. 4 sections. And we're going to cover those tonight. And a lot of people are saying, you're crazy. No, I'm not crazy, because y'all going to send questions afterwards. In other words, you're going to send questions. What's today? Tuesday?
Yep.
Wednesday and Thursday, you're going to send questions. And then we're going to go over it again Thursday night. And probably Tuesday night. And after that, you're probably ready for a test. So, what are we going to do first? Well, in 6.1 and 6.2, there's 3 type questions, but we're going to go over the first one first, and it's called probability distribution. Probability distribution. And probability distribution is when you have a table set up with probabilities. Now, there's only 2 rules that you got to remember about probability distribution. One is that the summation of your events, or the summation of the probabilities, is going to be equal to 1. That's pretty simple. Okay? And that each event is between 0 and 1. 1. So that's the 2 things that you have to remember about a probability distribution. If you have a negative in there, then that means it's not a probability distribution. If all of them added up equals 5.6, then that's not a probability distribution. So if they ask you that on a test, and you find it and you say, no, it's not a probability distribution. Now, they're going to ask you, there's 2 or 3 type questions that they're going to ask you. One is to create or construct a probability distribution. And then after you learn how to construct the probability distribution, they're going to ask you questions about probability distribution. And basically, it's just going to be simple math. Okay, adding and subtracting, multiplying, or dividing. Now, how do you construct one? Well, we're going to give you an example right here. A couple wants to have three kids. Construct a probability distribution with the probability of a male or probability of a boy being 0.42. Okay? Now, up till this point, the probability has been what? 0.5. What makes it 0.42? Well, let's say some of y'all, I don't know, some of y'all may be a nurse, I don't know. You ever worked on you know somebody that's ever worked on what's the floor that delivers the babies? What is it called?
Labor and delivery.
Labor and delivery, okay. And the nurse is there, they say, oh, the moon's full, we're gonna have girls tonight, or they keep tabs and find out what month is. I don't know if you know anybody, but I used to know a nurse that did that. They worked in labor and delivery, and they would bet on how many babies they were going to have based on what? History. Okay, based on how long they've been working there. Or if they have a full moon, that means they're going to have more boys than girls or whatever. But historically, they found the question says the probability of boy is 0.42. So what's the complement of the probability of a boy? Probability of a girl is what? 0.58. Okay. Now, this in the black is going to be given. They're going to say 3 kids, construct probability distribution with probability of a girl or a boy being blah blah blah. Well, this gives you that, and then you say, okay, well, there's only 3 possibilities. I mean, there's only 8 possibilities. Let's do them. Boy, 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 girl, girl, girls. And this is one of those things I told y'all you need to write down, you need to keep it, because they love to do standardized test questions about this. And I'm going to say girl, boy, 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 girl, boy, 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 girl. And then I'm going to go down here and I'm going to say boy, girl, 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 boy, girl, and girl, boy, boy. There's 8 of them. There's supposed to be 8. Okay? So now you're going to construct your table. This is going to be X, and this is going to be the probability of X. This is the event. This is the probability of the event happening. Okay? And the probability of 0 girls, probability of 1 girl, probability of 2 girls, and the probability of 3 girls. Or you could say boys, or whatever you want to do. I don't care. Okay, whatever the question asks. Okay, but is there any more possibilities? No. You're either going to have 0 boys, 1 little boy, 2 boys, or 3 boys, or you're going to have 0 girls, 1 girl, 2 girls, or 3 girls. Does everybody understand that? It's either one or the other. Depends on what the question's asking. Okay, they're just telling us to do a probability distribution. They're not asking you what the probability of a certain outcome is. They're just asking you to construct a probability distribution. And a probability distribution is this table. Everybody with me? Okay, so what do we do next? Well, you got to write down the probability. Give me the example of 0 girls.
4.1.
Okay, so we're going to put that right here. Now, we haven't done the probability yet. We're just going to write boy, boy, boy there for right now. We're going to continue this out, and we're going to actually do the calculations out here. Okay, that takes care of that one. Now, where is 1 girl?
Boy, boy, girl.
1 girl is all where? Right there, right? Okay, so that's 3 out of, well, write them down. GBB, BGB, and BBG. Everybody with me? Now you do 2 girls and 3 girls. We'll mark those out. Pretty simple. You should be able to figure it out. Okay, so here's the other 3, which is girl, boy, boy, girl, wait a minute, it's supposed to be girl, boy, girl, isn't it?
Yes, girl, boy.
Yeah.
Yes, you already have that one up there.
Boy, girl, 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 boy. There we go. Girl, girl, boy. So, girl, girl, boy, girl, girl, boy, girl, boy, girl, and boy, girl, girl. And then what's the last one? Girl, girl, girl. That's pretty simple. Okay? So now, if it was 0.5 probability, it'd be different, but it's not 0.5 probability. It's 0.48, 47, 42. So we're going to go over here, and we're actually going to do the math. So this one's going to be 0.42 times 0.42 times 0.42. Or 0.42 raised to the what? Third power. We're going to do that in just a minute. What's this one? Well, let's see. 0.58, 0.42, 0.42. Plus 0.42, 0.58, 0.42. Plus 0.42 times 0.42 times 0.58. And then down here, 0.58 times 0.58 times 0.42. Plus 0.58 times 0.42 times 0.58. Plus 0.42 times 0.58 times 0.58. Now I want you to look at those two middle ones right here and tell me if you can't rewrite that a little bit shorter, a little bit more condensed. And what's the third one? 0.58 raised to the what?
The third power.
Third power. Now you can rewrite these right here a whole lot easier. See if you can come up with it. Meanwhile, I'm going to erase all this over here. So I'm going to rewrite my x, p of x, 0, 1, 2, 3. Somebody take 0.42 and raise it to the third power. What do you got?
0.074.
I'm sorry, what?
0.074.
And give me the last one, 0.58 to the third power.
0.58 to the third.
Yes.
0.195.
195? Okay, now, how else can you write this? Right, the second one. Well, each one of them has 0.42 to the times 0.42, right?
Yes.
So you could say 0.42 to the second power, right?
Yes.
Times 0.58 and multiply that by 3. So we could rewrite that as 3 times 0.58 times 0.42 to the second power. And work that out. What do you get? And while y'all are doing that, the second one will be 0.58, 3 times 0.58 to the second power times 0.42. Okay, so what'd you get on the first one?
That one I got 0.424. That was bottom.
The bottom one, what?
0.424.
And what about this one?
346.
Add all these up. Add all those decimals up. Tell me what you get. .074 plus 0.346, 0.424 plus 0.195. What do you get?
I got 0.307.
What?
For number one. Yeah, I got it wrong. I'm sorry. Did it wrong.
Miss Poor, keep her quiet, okay? She's not supposed to talk. What'd you get for the first one and the second one again?
0.307.
307. All right, now add them all up. 31 and 42 is 72, or 73. That's 93. Yep. Should equal what?
1.
1. All right, so we can erase this. And now you have your probability distribution. I'm going to move these over, 0.307 and 0.424. And this is what we call a probability distribution. That's how you do it. Okay, so that's one question you might get in the homework. Construct a probability distribution. First thing you do is do your sample space, sample set, sample space, whatever you want to call it. That is when I wrote down the boy, 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 girl, 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 boy, blah, blah, blah. Okay? You can do that first. Then you look for this probability. Now, what if it doesn't specify? Then probability of a boy is what? 0.5. Okay? If nothing is given, this is an assumption. Write that down. Okay? Or you can just count and say, okay, well, there's 1 out of 8, so that's going to be 1 out of 8, which is something. This is 3 out of 8, 3 out of 8, and 1 out of 8. If it was 0.5, you could do that. But it's not 0.5 in this question, so we can't just count it. All right, now, what else will it say? Well, maybe it might say, another question you might get in the homework or the test, after they give you a probability distribution, they may say, well, what's the probability of, so this is the first type question you might have. The second type question in 6.1 might ask you, well, what is the probability of at least 1? What does at least 1 mean? That means the lowest number is 1, right?
Yeah.
At least 1 girl, or what do we say? 0. We said 0. Yeah, 0 girls. 0 girls, 1 girl. Okay. So you would add up these 3 right here, because at least 1 means at least 1 what? Girl. So 2 girls, that would count, and 3 girls would count. So you add those 3 up.
So the same as like the probability of 1 or 2 or 3?
Mm-hmm. Same thing. So 0.73, 0.73, 0.93, something like that. It'd be, y'all get it closer if you do the decimals to the third. That's just approximate. 0.93. What is the probability of 0? Well, that would be 0.074. So you're just reading the chart, okay? Reading the table. Now, the most boy, 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 girl, 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 that's one question. The other one is a certain amount of people on a jury. And they'll say, how many are women? Or how many is at least blah, blah, blah? Or how many are men over 65? And they'll give you all that information. But that's where you see that type question. All right? Now, the rest of Chapter 6 is based on NPX. What the heck is he talking about? Well, the rest of Chapter 6, which will probably be 6.2, okay? And that is going to be NPX. Everything is based on NPX. The type of question they may give you is a coin is flipped 75 times. The probability of tails comes out to be 0.52. What is the probability of tails if you flip another 25 times? Everybody with me? flip another 25 times. What have I always taught y'all about n from the first week of class? N is always your what? Bigger number. So which one's n?
75.
75. 75 is n. Write that down. N is equal to 75. I know most of y'all would like to sit in here in the dark because you probably go to sleep, but I can't let y'all do that. All right, so what is P? What does P stand for in probability? Duh. Probability also stands for percentage. It can also mean area, but in this section, P is what?
The probability.
Probability, which is 0.52. So, come on, people. I have faith in you. Then what do you think X is? 25. The only number what? Left. Now, it's very important that you follow this order because I need you to look in your calculators, and I think it's called, oh gosh, I can't ever remember this one. I think it's second bars, and then I think it's binomial PDF. I think there's a binomial PDF and a binomial CDF. Y'all look, tell me what the numbers are.
It's actually letters in mine, A and B.
Okay, A and B. Is PDF first?
It is.
Okay, we're gonna have to do both of them because I can't remember which one's which, because I don't use a calculator that much. I'm doing good, just remember that. All right, so let's go with binomial PDF first. Okay, one of them will give you an error, the other one won't. So second bars, and then binomial PDF is going to give you a parenthesis. And what do you think you're going to type in? You're going to type in 75, comma, 0.52, comma, 25. And hit enter. Tell me if it gives you an error. I didn't hear you.
No.
Okay, what did it give you? Okay.
I got one.
Nobody got an answer. Y'all really
Gave me an
suck.
error.
It gave you an error?
Yeah.
Okay, do CDF.
One.
Do CDF.
I got.
I didn't get there.
I'm trying to figure out how to read this.
Oh, I mean, it's just 3 buttons. I mean, the second bars, binomial PDF.
I got 4.8.
That's not it. So try CDF. Try the other one.
Okay.
I got scientific notation.
Oh, well then you can't read that. You're in calculus. You can't read that.
That's what I got too.
Okay, well then that's probably the answer. What does CDF give you? Some of y'all will say, it gave me an error too. I'm sorry, what?
0.961.
0.961. That sounds better. 0.961. So it's CDF. Okay, don't use PDF. Check it and make sure you get the same answer. Because I don't trust y'all, especially in the front part of the room.
The first one I did is kind of close to, the first one I got 1.886. So that's
Okay, that's scientific notation. That's
okay.
probably not going to be it. It's going to come out with a probability like 0.92, 0.38, something like that. Try CDF and see if you came out with 0.961. If not, we'll look it up later in the book.
Yeah, I can't get mine to do either.
Mine is not even, it keeps saying
One
error.
says -1.
I don't know.
Mine's still doing that.
Just let me do it. Just everybody, just sit down and be quiet. Cause y'all break an amble with a banana, I swear. Give y'all something simple, and what do y'all do?
Make it complicated.
It's not us, it's the calculator.
Yeah, it's just the calculator's
It is
fault.
the calculator.
It's the Russians.
It's the Nigerian.
It's Nigerians too. And Chick-fil-A is racist. Y'all ain't heard that yet? If you eat at Chick-fil-A, you're racist. There we go. There's our handy dandy
Okay.
calculator. So, second bars. Hold on a minute.
Okay, we're there, we're right there.
Should say, where's the binomial? There it is. Binomial PDF,
Okay.
and then trials, that's N, that'd be 50.
Okay, so we're doing PDF.
Or CDF,
I'm checking both,
Okay.
because I'm not relying on y'all.
okay,
0.52,
so,
and X value is 25. Now, go ahead and look at the screen. Some of you may have a newer calculator. The newer calculators do not put it in parentheses. It just asks you. And trial, that's N. P is P. And X is X. And you type it in and you hit enter and paste. And it's going to stick it. Now, see, if you have an older calculator, that's what it's going to look like. Okay? And hit enter. And that's going to be 0.00048. Now let's look at the other one and see, because I don't know what's the answer, so I just made this problem up. So second bars, was that normal? Was that CDF or PDF? That was PDF. So let's do CDF. And that's going to be 75 and 0.52. And 25. Paste. And enter. Okay, that's even lower. That's like 0.0008. Okay, 0.0009. So I'll have to look in the book because I honestly can't remember, and I'll look that up right for you. Hold on, let me look it up. Because some of y'all are going to spaz if I don't tell you because y'all have OCD or whatever. Y'all don't have OCD, do you?
mm-hmm.
Okay. Everybody has something, right?
You gotta admit first.
Some people have DAD. You know what DAD is? I'm just asking y'all. I don't know what it is. I mean, some of y'all know what DAD is? Okay. I'm going to get in trouble anyway because in my calculus class this morning, I said that men are stupidly predictable, which we are. And women, you can forget it. You can't predict a woman. And I know I'm going to get in trouble for that. What?
You gotta say everything you said.
No, I'm not going through that conversation again. But it's true.
Did you post it on YouTube?
No. And I'm not going to post that one on YouTube, no. When a woman says fine, that means, oh, hell no.
I think that's one of the best.
And some of the dumb DA guys, they'll be, okay, I'm going with the guys. Fine. Yeah, that don't mean fine. That means, oh, hell no, you better not do it. But see, some guys don't know that because they haven't been taught. So, women are very unpredictable. And I know somebody's going to call my boss and complain, say they were offended.
But you can predict that if a woman says
It depends. Sometimes you'll do fine. It's how it's said has a lot to do with it. How it's said. If it's got a D in front, fine. Oh, hell no.
We just want to express how we feel.
No, hell, y'all don't. Y'all just, no, you don't. I don't even want to hear that crap. All right, let me look y'all up and find the dadgum chapter contents. I said this is 6-1. Let's see if I can find it right quick. I always forget this one. I don't know why I forget this one, but this is the one I forget. So give it a couple of hours to discrete random variables. That's what we're talking about that. Where is the... we already talked about that. That's the binomial distribution, probability distribution. Oh, we got to do that too, but I'm not doing that right now. Okay, so it's 6.2.
In the book, it uses CDF.
Thank you. What page is that on?
319.
Well, I was getting there.
Minus 3 months.
316.
Look up there. No,
Yeah, there it is.
Yeah.
Binomial CDF. Okay. Let me look. Let me go back. That's a little bit too far. Let me see if that's still. Is that? Yeah, that's 6.2. As long as it's 6.2, because that's all we cover. God, 6.2 is like 15 pages long. I'm just looking to make sure. I don't want to tell. Yeah, this is it. Yeah. So use normal CDF.
CDF.
Yeah, it's on page 316, right there.
Or you can look on.
Cumulative distribution function. Everybody write that down, even if you're talking to each other. Cumulative distribution function, CDF. So mark off PDF. Don't even use that, because we don't use that in this section. And I'll forget it next semester too. Okay, CDF. Okay, so you're going to be asked that type question, and then you're also going to be asked, while I'm there, you're going to be asked this type question. Let me just blow it up a little bit for you. Write that bottom box down on page 316.
Yeah.
The mean is n times p, and the standard deviation is n times p times q. Q is the complement of p. So if I tell you the p is equal to 0.4, what's q?
We're writing.
Okay, I gotta wait to. I got females in here. Y'all are supposed to be able to juggle things, okay? If P is 0.4, what is Q?
Where is Q?
I'm asking you. Don't worry about writing anything down. I told you that Q is the complement of P. That's what I just told you.
Okay.
Okay? So if P is 0.4, what is Q?
0.6.
Okay. 1 minus P is the book's way of saying Q. All right? They don't think y'all got sense enough to know what Q is, so they write it out for you. It irritates me. Okay? Most books have NPQ. Q is the complement of P. And you're going to see that in chapter 7 and 8 also. I mean, in chapter 8 also, P hat, the complement of P hat is Q hat. Which is got a little hat on top of it. Okay? Now, this is very simple. They say, okay, you got 400 people that work at blah, 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 and 60% of the people there are sick. Okay, you just multiply them together. Okay, that's the way you do that. So we're not going to touch that right yet. I want to go back to the normal CDF because I want to find a problem. But that's 6.1 and 6.2. Now I'm going to show you more about the mean and the standard deviation. We're going to visit that probably Tuesday or Thursday. Okay, but let me go back and get you a problem with this one right here. Let me make sure because it should be normal CDF. Yeah. Okay, according to Gallup organization, 65%, ding, what is 65%?
The probability.
Probability or percent, write that down. Probability or percent, P, start with a P, are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, what is the probability that 10 favor the death penalty? Well, that's going to be exactly 10. What's going to be N? 15. What's going to be X? 10. Okay. Now, what does no more than 6 mean? That's when you need to mark it on a, that means you need to write it on a, no, it's those things that we've been studying since kindergarten. Number line. Okay. So let me get my handy dandy.
I just said that. You said
I
no.
can't hear y'all. Y'all don't talk. This
I said number line. You said no.
okay, I can't hear them. No, I don't like you, this cheater. That's why I ignored you. Okay. All right. So it said 6, no more than 6. When you see at least 1, or you see no more than 6, the best thing for you to do is draw it on number line. Okay? Now, some of y'all don't need it because y'all invented the number line, right? Okay? Buddy, if I read a question on a test, the first thing I do, if it says no more than this, or at least this, or da-da-da-da, I put it on the number line. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, and it goes up to, I think the question said 10.
Yeah.
Okay. I'm not going to go to 10 because you don't need it. Well, we can. 9, 10. And what did it say? At most what? Or what did it say? No more than 6. So what does no more than 6? Take your eraser. You're not going to go past what? So you're going to have to add all those up. NP1, MP0, MP1, MP2, MP3, MP4, MP5. Or you could do 7, 8, and 9, and 10, and subtract that from what? 1. You could do the complement. Okay? But that's what they're doing. So we're going to do the first one. Just go ahead and type in, what was N, 15?
Yes.
Let me get back there.
Do we need to change it to 0.6?
Yes, you have to always change it to a decimal. The calculator will not take percent. So N is 15, P is 0.65, and the first one is 10. The X is 10. So we go to our next page and see what y'all get on your calculator. 0.2123. You didn't get that? Well, I don't know what. Unless they got a table. Hold on, let me see if they got a table. They might have gave you a table. I don't think they did. What did y'all get when you did NPX? What did you get with normal CDF?
We get exact if you do PDF.
Huh. Hold on a minute. Let me see if they're using both, because they usually don't use both. I'm looking. It says continued, and then it says, I'm trying to see where they're getting it.
Yeah, that's PDF.
And then down here, they tell you to use CDF. That's unusual, because usually it's the other way around. Okay, use PDF on that one. And the reason it's saying binomial, we'll go back over it. See, down here, they're using CDF. I'm looking over it right quick. Okay, we'll go back over it. I don't understand why it's doing the PDF and the... Why did they show you CDF when they're doing PDF? Just give me a second. Just hold on. We're not going anywhere. Just... PDF, probability distribution function. There it is. So they do introduce both of them. I didn't know they introduced both of them in this book. Okay, so this one, okay, when I told you NPX, the first part is PDF, okay? And then when they'll tell you, it'll say binomial probability distribution. It'll say binomial.
That's when we use.
Okay, that's when you use PDF. So you need to write down binomial probability distribution, PDF. That's the first part of that question. And that's when you type in NP and X. I didn't know they did both of them in this book. This is the second semester we've used this book, so. Okay, so on that first part of the question, they say, and then CDF. Let me find the question again. Exactly is when it's by, okay, exactly, I didn't catch that. Exactly is when it's exactly on it. That's when it's PDF. And then no more or less than or at most or whatever, that's when it's CDF. And that's what they're doing on the next page. So binomial PDF will be there. NPX, X is equal to 10. But we'll go over this Thursday. I want to get to 7, if you don't mind. I want to get to 7. Also, let me give you an example of this one. Here's the easy one. Okay? According to, and write this down, according to CT blah, 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 41% of all U.S. households are wireless-only households in a simple random sample of 300 households. 300 is what? N. P is 0.41. So what is Q? 0.59, Hubert. Yes. Okay, now you're going to need Q later, but take your calculator and multiply 300 times 0.41. That's your mean, 123. That's all you do. 123. Should be 122 point something or 100, rounds to 123. Okay, now, what do you do with 123? You multiply it by 0.59 and take the square root of it. So take 123, multiply by 0.59, and then raise that to the 0.5 power. Tell me what you get.
8.7.
8.5, whatever. It's 8.5. Anvil, banana, 8.5. And that's your standard deviation. So that's how you get. And we'll go over problems like this Thursday because y'all going to send them to me and we're going to go over. But I just want, see, right now, I don't know how much y'all know about Chapter 6 and Chapter 7, because this is actually the first time we've done something that y'all might not have a clue about. So what I'm doing is I'm throwing it out there, let y'all go home and work on it, and let y'all dictate what I go over Thursday. Does that make sense? If nobody sends me Chapter 6 material and questions, then I don't have to cover Chapter 6. That means y'all understand it. Now, if you're going to procrastinate and not do any of the homework, then don't cry when I'll get ready to do the test and you're saying, oh, I need the question. No, it's too late then. Okay? Now, Chapter 7. Let's go to Chapter 7. Let me go to the whiteboard. Chapter 7 deals with area under the curve. Area is probability. Probability is percentages. Now, there's three type problems in Chapter 7. Uniform distribution. Uniform distribution. What's the only thing that we don't have control over? What's the only thing that humans cannot control? Time, even though some women try to. That's really embarrassing. If you've ever been to a dance recital or a cheerleading recital, it's not pretty. Because the moms try to wear the, yeah, y'all know what I'm talking about. Finish the sentence for me. What am I saying? They try to what? Exactly. They're trying to go back to when they were at the cheerleading recital or a dance recital. And you know, very few mothers can pull this off, okay? Very, very few. Like 2% of the population, okay? It's really embarrassing, women. Don't do it, okay? All right, so why is it a rectangle? Because no matter how much you want to influence time, you can't. So that's why it's a straight line. That's why it's not a curve. Then you have our old friend, the normal what? Distribution. Yep. Now, there's one question that you're going to do with this type problem, and then there's two type questions that you're going to deal with this type problem. Okay? This type, you got to remember the empirical rule that I told y'all to memorize. Remember the gas gauge, fuel gauge? Remember me telling you, I don't know how to spell gauge. Is that right?
Yeah.
And then 3, you're going to have to also learn how to change things into what? The z-score. What?
Thanks, okay.
GH.
Yeah.
Is it? I thought it was G-U-H. No, there is a, somebody look it up. There is a way you spell gauge, and it's not 4 letters.
Yeah, G-A-U-G-E.
G-A-U. You sure? That's gouge. Okay.
How is that gauge?
I don't know. I told you I couldn't spell it when I did it.
The name gauge G-A-G-E, but like gauging your ears like G-E-G-E.
I just know there was a U somewhere. I thought there was a U in it. Is it G-A-G-E?
G-A-U-G-E.
G-A-U-G-E. Okay, I did.
Yeah.
There is a U in there.
I just put it in the wrong place.
There's no such word as G-E.
I think we've already established that, Mr. Polar. All right. Now, here, area of a rectangle is equal to length times what? Width. All right. So what you're going to have to find here is the height, because the area is 1. Now, I wrote that in 4 decimal points because when you see 4 decimal points in Chapter 7, that means it's area. Area equals percent, area equals percent, or probability. All 3 of them are the same thing. Okay? So, if you see 0.4967, you know that's an area. If you see 0.5000, you know that's an area. 4 digits, 4 decimal places mean you're dealing with an area, a percentage, or a probability. One of those 3. Okay? 2 digits, and let's write that down. 4 decimal points is an area, or a probability, or a percentage. 2 decimal points means z-score. So you need to write that down and highlight it because that's very important. Now let's go ahead and talk about the question you might see with a uniform distribution. Math 120 usually lasts 55 minutes. What is the probability that the class will end at 45 minutes? Okay? So the first thing you do is establish your base. The base here is 0 to 55. So now that you have a base, you've got to find the what? The height. So set 1 equal to, what's the base? The base is 55 times W or H, whatever you want to call it. All right, so here we go. 1 is equal to 55 times height. Divide by 55, divide by 55. Now I'm going to leave it as a fraction because it might be easier math to do it that way. What was that? Okay, so height, let's erase our handy dandy question mark. Now we're going to put, I'm going to put it in blue because we figured it. 1 over 55. So now we've got our height, and the question will say, what is the probability that the class goes over 45 minutes, or at 45 minutes? Well, 45 would be where? Right back here. So what's our new base? What's the base between 45 and 55? 10. So 45, that'd be equal to 1 base times what? Base times 1 over 55, which is equal to 10 over 55. Somebody give me what's 10 over 55? Point what? 4 digits. 4 decimal points.
0.18.
1818?
Yeah.
So there's an 18% chance that the class is going to go over 45%, 45 minutes. That's how you do the time problems. Now they may be reworded, I'm not wording it perfectly, okay, but it'll be having to do with what? Time. Now on a test with 20 questions, you're probably talking about 2 or 3 questions from this. Most of the questions are going to be there. Okay, so let's go ahead and talk about 2 and 3. While y'all are still writing, let me check times and then everybody goes into convulsions. Now I do want you to watch this video as well as the video from the AM because it goes over the same stuff, just different numbers, and you know, you can get double the exposure to those problems. All right, the first type question will be like this. They'll give you a normal curve or a paragraph talking about a normal distribution. And the first type question, the mean is equal to 0 and the standard deviation is equal to 1. Therefore, you have your standard z-score table. 0, 1, 2, -1, and 1. -2. And the empirical rule is 2.5, 13.5, 34, 34, 13.5, and 2.5. Now, you don't have to write that in there. You can just remember it. And remember, your gauge is 50%. Half a tank. This is around a quarter tank. This is empty. This is 3/4, and so on. Just so you'll have orientation. And they'll say, they'll either give you the probability, area, / percentage, and you find the z-score, Or they're going to give you the z-score, and you find the what? Probability, area, or percentage. Probability, area, or percentage. Now, if they give you the probability area, you're going to use second, bars, inverse norm. Somebody give me that number that's on your. Which one says inverse norm? Under second bars, which one says inverse norm? What number?
3.
3. So let's say, give me, now you got to use the empirical rule before you use the calculator. So let me ask you this. Let's say I give you the 60th percentile, all right, P of 60, meaning the area is 60%. You're going to say, well, wait a minute, 60%, that'd be where? 60% be, this is 50, this is 34, so that's 33, 33 right in there, so that's 3. I'm breaking it up into 11. So this is 11, this is 11, this is 11. What's 11 times 3? 33, okay? So that's 34, give or take. So what is 50 plus 11?
60%.
So 60 would be where? Right in there? Now that's a third of the way. So I'm going to say the z-score is going to be around 0.35. Everybody see how I got that? That's what you do with the empirical rule. You check before you even do the calculation. Now, do inverse norm, and then type in 0.6000. You don't have to type 4 digits, but I'm doing 4 digits for instructional purposes so you'll know it's area. Okay, somebody tell me what you get. Okay, I'm off a little bit. 0.25, is that what everybody got? 253?
Yeah.
Give me a fourth one.
3.
Okay, I said 33, 35, it's
Or are we rounding it?
4 digits, all I need. Okay, so that's how you find the z-score. Now let's do it the other way. Let me give you a red z-score of 1.5, negative 1.5. So I'm giving you z is equal to negative 1.5. So I want to find the area right here up to 1.5. Somebody tell me what's 2.5 plus 6.
8.5.
So I think it's going to be around 8.5%. How did I get that? I took half of 13, which is what? 6, 7? 7 plus 2 is 9.5. We can do 9.5. I'm going to say it's around 9.5%. What's this arrowhead called down here? Negative infinity. So you got to go 9999. Do second, bars, normal, and I can't remember which one it is, CDF or PDF. I don't know why they do that. CDF or PDF. Let's do CDF and go from negative 9999, comma, to negative 1.5. Close parentheses and enter. See what you get. Normal CDF, let's do CDF, negative 9999 to negative 1.5. What do you get? Second bars, normal CDF, parentheses, negative 9999, comma, negative 1.5. Somebody got it? Y'all done gave up on me.
Negative 0.01. I'm sorry. Negative 0.09.
Yeah, that's not it. Try PDF. Let me pull up the calculator and try PDF. How do I know it's not that? Because it's supposed to be around 9.5%. So let's see which one it is. Second, bars, normal PDF, X value is negative 1.5, negative 1.5. I don't think that's right. It'll be the other one, CDF. Let me go to CDF. That's not it. Second bars, CDF. Let me see what it is. There it is. So I'm going to type in negative 9999, comma, negative 1.5. Close parentheses, enter. Enter. There it is. Okay, I'm off, way off.
I got something different.
What'd you get?
0.066.
That's what I got too.
0.398.
I think
Did I
you're
type
still
in
on
something
CD.
wrong?
I think you're still on PDF and then you.
Oh, okay, let me do that again. All right, let me clear it. Normal, second bars, which one did I pick? CDF or PDF?
Do CDF.
CDF.
CDF is the one that, okay, that didn't show up the first time.
Yeah, because you were still.
Okay, negative 99999, you can type in 5 nines if you want to. Negative 1.5, and enter. There we go, 6.7%. I said 9.5, I'm sorry. Okay, so 0.0668, write that down. You were right, 0.0668. Now again, don't spaz because we're going to go over this again. So this is .0668. Okay, now what's the other one? What's the third one? Here's the third one. Give you a normal curve. And what's the difference between this one and the last one? This one is going to give you mu is equal to 100, and the standard deviation is equal to 20. Oh, you got to fill out the picture. Yeah, this will be 100. This will be 120. What will this be? 140. What will this be? 80. What will this be? 60. And it'll ask the same thing, but this time you're going to have to change it to a z-score. Let's say I want to find the area. I'll do it in blue. 0.5800. Okay? 0.5800. Well, they've given us an area, so that means we got to find the what? Z-score. But that z-score is not going to make any sense because you got 100. This is about 110. This is about 120. That z-score is not going to make any sense. So you got to use this. X is equal to Oz plus mu.
Is mu the area right now?
Mu is just 100. That's the mean.
Okay.
Right here.
Okay.
Okay? So, somebody, since you got an area, you're going to do inverse norm. So, second bars, inverse norm. Somebody do that for me. And you're going to type in 0.5800. And tell me what you get. It's going to be a z-score. It's going to be between 0 and 1. What is it? I like to hear an answer that doesn't go down at the end. 0.2.
0.01.
201 is 20. That's
0.2019.
That's good. All right, so that goes right here. Okay, what goes right here?
The 20.
20. And 100. Now somebody take your calculator and crank this out. Let's say this is test scores. What test score represents 58% of the population? Somebody crank it out.
400.
104.
Look at here. It's between 100 and 120. What'd you get?
104.
Does everybody get 104? Okay, that's your answer. So the test score of 104, what if you make 103? That means you're in the bottom 58%. What if you make 120? Then you're in the top 42%. Capiche? Okay, now what else can they give you? This is the other part. They can say this. What percent is at 130? Test score of 130. Well, what do you got to do? The first thing you got to do is change 130 into a z-score. So z-score is equal to x minus what? X bar over standard deviation. Y'all know that from Unit 2 or Unit 1. Unit 1. So 130 minus 100 over 20. Somebody give me that z-score. Where's it going to be? It's going to be between 1 and 2. So it's going to be, if you get 5.6 and you're wrong, it's going to be between 1 and 2. What is it?
Is that an S or a 5?
1.5.
What are you talking about?
Z equals an X.
Standard deviation, that's a S. Standard deviation.
All right.
I'm sorry. I thought you were talking about the Z right here. I didn't know what you're talking about. Okay, so 1.5. So what do you do now? Well, you got to find, here's 1.5. And what's this arrowhead called right here? Positive infinity. So let's say you want to find the number of students above, the score above 130. That's this area right here. So somebody type in, which one did we use? Normal CDF or what was it?
Yeah, normal.
Okay, normal CDF, and you go from 1.5 to what? 9999. Well, let's see, that's 2.5. 2.5, and this is half of 13.5, which is 7. It's going to be around 9.5%. So what does it come out to be? Now, mine's an estimate.
Do we still do, we have to change the meter and stuff, right?
Okay, this might be the one that you use the other one, CDF, or CDF, because it should have, you should be able to punch in 120. See what it says. No, you don't have to, no. You already, see, this is a z-score that comprehends to 0, 1, 2. So yes, use the normal, first one, PDF, and go 1.5 to what? To infinity, 9999. And what do you get? I say it's around, it'll be 0.095 or 0.085, something like that. I'll do it.
0.0.
Okay, 0.0 what?
0.0668.
Okay, there you go, 0.0668. I'll do it, check it. So second entry. And I'm going to go from, what did I say, 1.5, comma, 9999. I'm going to move over a little bit so I can see it, comma, 9999. I'll just fill these up with 9s so you it don't matter how many times I put it in there. .0668, so 6.68%. So how much of the population scores above 130? 7%, or 6.66, what was it, 6.6 what? 66% or whatever. And that's the 3 type questions that you're going to have with the Chapter 7, Chapter 7.1 and 7.2. So you can see, is there a lot of math or is there a lot of calculator work? A lot of calculator work. So everybody should make an A on this one, especially if you're on a calculator drill team. All right, y'all get out of here. I'll give everybody a here. Work on 6.1, 6.2, 7.1, and 7.2 homework. Send in questions. Thursday's class will be determined by how many questions you send in. Bye, Miss Sullivan.